had 4 consecutive failures on my molds, and on the 5th one I had success because I had to reprint my mold. Now the original mold started to break here on the edges as I was hammering it, and because the printer left a ridge here, the print was interrupted by a power failure. It left a ridge, and that was also creating problem for me. And my infill pattern on the printer was set to cubic, and as a result this one edge lifted from the bed, and so all in all it was a win for me to reprint the mold. Now the new mold, I've reprinted it with a 4-degree draft angle instead of the 2-degree draft angle on the previous mold, and that left me with a successful pattern on the sand cast in the flask. So yeah, now I can pour the metal and then start the machining. Okay, the back of the casting is reasonably flat, so I'm going to use that as the reference. And I've clamped it on my forjaw, and I've just used the jaws to do my alignment, because this is a rough casting and it's running pretty straight and through as well. So I'm going to clean up this face here and the sides, and then drill a hole through the middle. And that is, I'm going to use the hole in the middle to pull it down back into the chuck again, because I don't have a chuck big enough to hold this casting. My forger, even if I go right on the edge, it won't fit. Okay, I've decided against just drilling a hole for a bolt. I decided to open it up to the final bore size that I want, because it's going to allow me to flip it around and clamp it in a 3-jaw chuck and then do the back face. Now if you're wondering why I'm making such a large hole, it's because on this machine you've got a problem that you've got a very narrow spindle bore. It's a MT4 taper. I think it's around 30 odd millimeters in diameter, and when you want to turn a piece of plate and you want to do a bore on the inside up to 50 millimeters, you always have restrictions and chuck jaws and everything that's in the way. So I want to make sure that I've got a nice large hole. This is over 60 millimeters. I think it's 67, so that I can do a bore up to 65 millimeters without touching the faceplate. So yeah, I think it's going to turn out very nicely. Okay, you saw me center find. I first started with my X axis and then I went to the Y and went back to the X again. Reason for that is when you're doing a edge finding in a circle or an inside bore, especially if it's something sticky like aluminium, you'll find that your edge finder won't be 100% true in a bore if it's offset by a little. Say for argument's sake, it's the edge finder is more towards my hand. On this side, it will be conventional in terms of end mill will be turning in a conventional manner. So the behavior between this surface and this surface will be different because this side will be more like a climb cut. So the reading will be out. So you use your X to get as close as possible to the center, and then you do your Y. Once you've done your Y, you go back to your X, because then your two edges will be center on the center finder when you touch off, and the behavior of the edge finder will be exactly the same. Because I have found that I get discrepancies if I don't do it the second time. So it's just a little tip that I've picked up from experience. The faceplate is done, and I'm happy that I've got no run out on it. And I still need to make fixtures that's going to bolt into the back to extend my range towards the outer rim. And what it will do is it will bolt in from the back, come around, and then sit on the outside of the faceplate, which will give you the option of running parts right up to the edge of the faceplate. Now this part is too thin for T-slots, I don't have T-slot cutters anyway, so that will be my solution. And I'm happy with this. I think it will serve my purpose for the shop. So I hope you enjoyed it. Until next time, cheers.